All right, hello everybody. This is the next lesson here, lesson 27 in the quadratics unit. And so we're going to look at how we can use the technology available to us to be able to use equations of quadratics in application settings, and all of those key values that we know to recognize and look for have answers to things and questions. So let's just get right at it and do an example, and then I'll set you free with the practice questions. So for example, here, this equation represents the path of the ball. It's a quadratic shape. And so if you graph it with GeoGebra, or you could graph it by hand, right? It says up here, note, you could graph it by hand. But of course, that would take a lot of effort and time, and you wouldn't have as much time to be willing to think about the meaning of each of the spots, right? So the idea is to get you used to the idea of the meaning of each of the spots that are important in quadratics. And then later on, we'll see how to determine those spots in a fancier way, okay, rather than just tables of values. So here we go. We have Allison planning a fireworks show for Canada Day, and music and so on, and there's an equation for the path. And notice here we've got a quadratic kind of path, right? So terrible drawing. I drew it with a mouse, so it doesn't. It's harder to make a nice quadratic shape. That one's a little better. Drawing with a mouse. Anyways, so this is the equation here, right? So that equation, we plug that into GeoGebra, we're going to be able to get lots of information about this firework, right? So we'd be able to answer things like how far up it went, and how far over, I guess, how long. It's t, the horizontal axis in this case is t for time, right? And so h for height and t for time. And so how high up it goes and how far over it went, how long later it lands, and so on, right? Saying how far over, because quite often it is a distance as a horizontal as well. So let's get at it here. Again, Google GeoGebra, click on the link or whatever. I've got it ready to go here. So let's go up to GeoGebra, and we want the equation negative 4.9 t squared. So negative 4.9, and you can actually use t's. Have to, but oops, looks like I'm not clicked on the thing. Negative 4.9 t power of 2. So there's part of the equation, and plus 39.2t plus 39.2t. Click it here every time. Plus 39.2t and plus 2 plus 2. So that's giving us the equation, and you can tell it's like, oh, geez, we're not quite looking at this thing close enough or whatever, right? So you have to, or too close, I guess. So move this thing around and zoom out so we can see this thing, right? And so you can eventually get to the point where you can see that the firework went way up and then came back down. I wish there was a way to just drag there might be, if someone finds it, let me know, but some programs allow you just to drag the scale and stretch it. Whereas this program, the way I've done this was the fit isn't great, actually. Control Z. Allow me to undo. There we go. What is it? Settings. Yeah, there we go. So on the X scale, you want to sort of stretch it out, right? So instead of going to 158 on the X scale, let's make it just go to whatever it's going to here. Oh, I know actually a better way. We'll just change this thing here. So we'll make the X scale go bigger or smaller. I think it may have to do with 0.5. Hit enter and see if that looks better. 0.5. What's it doing here? If that looks better or worse. Worse. So then you can go the other way. So I'll make this one be like 10. And this one be 1. It's kind of behaving weird right now, but we'll get the idea. So I think it's because they're locked right now. So try this. I haven't done it in a little bit. Or there's a way to do this, but it's just behaving strange. If I make that be 10, just to change one there. And if I zoom in, might have to do another tutorial on that, but because like, how did I get there again? Anyways, it just looks better now, right? You can see like the path that it went and so on. If you click on it, it's going to allow you to find the maximum height. And so what this is meaning after, if this is t in seconds, right? That's after 4 seconds, got to a height of 80.4 meters, presumably. And then if you look at the rest of the numbers here, you can see, it landed after 8 seconds or so. Over here, if I zoom in, you can see the detail here. It didn't actually get launched from the ground. It got launched from a height of 2 meters. So presumably that's where like the launch pad is for the fireworks show or whatever. They're launching it up over the horizon or whatever. So it was launched at time 0 from a height of 2. There is this weird number back here where it's like instead they could have launched it earlier in time, so before it was launched from the ground, and it would be an equivalent path and so on. You can see it's pretty easy to zoom in around, and that the only thing that I'm wondering about you might need help with more is just changing the aspect of the thing so that it's not as tall and skinny as it was. But in the settings here, I just needed to change the axis to be in a different ratio, right? Instead of 1 to 1, right? 1 to 1, and then hitting enter. As you can see now, it's going to be that tall, skinny graph again. And so if I go to settings and change this to be a 1 to 10, then it goes back to where we were. So it's pretty easy once you see how to do it. I was just looking in the wrong spot for a second there. I'm trying to change the max min values, but this is just the maximum minimum that the scale is going to. So when you zoom in or out, you can see it goes to bigger and bigger values, and so on. So that's not the area. You want to just go on the X to Y axis ratio, okay? And it's either locked or it's not, right? So if you have it unlocked, then you can change it so it goes wider in comparison to the height. All right. So I will screenshot that into the lesson as well. Let's do this actually. Let's go show special points and screenshot that in. Got a nice record of everything that the technology was able to show us to do with this thing. So like I said, you can tell here that this spot right there, the C, is your extreme value, and it's a 4 and an 80.4. And the question should have been described a little bit more clearly, where the T was time in seconds. And the H up here is like the H, that's your height in meters. So then you could say, oh, look at the maximum height is 80, so max height 80.4 meters. And it was at, right? It was after or whatever, 4 seconds. Then we can look at this spot down here, which is the B point. So 8.05 seconds later it lands. So the firework lands after 8.05 seconds. And it was even actually a little hard to tell in the details here, but when I zoomed in the video, you could see it was actually launched at time 0. From a height of 2 meters. Right, so lots of good details there that we can figure out. Yeah, and so even other things we could do later on, I'll just add this on for fun here. If I were to graph a y equals, let's say 40. So that's not the way to do it. Y equals 40. Picky. So if I put a y equals 40 line in, then you can also see, it should actually this right there. If I click on that one, it's going to give me interesting spots, right? And so if I were to, for this one here, put special points, then it's going to give me intersection points of all of them. It doesn't seem like it's giving all of them. So it has the 0, didn't list them for me, so I'd have to take screenshots of each one. But you can see that this would tell us, oh, the fireworks at a height of 40 meters after 1.12 seconds, and then it's back down to a height of 40 meters after 6.87 seconds. So there's lots of cool things we can easily do with the technology. Whereas if we're trying to do that mathematically, there's some work involved, right? We're going to learn how to do it later on. There's some extra process that we need to learn first. And of course, it just involves a little bit more work as well, right? So more learning and some more work, but pretty cool. The technology can do that so nicely and easily for us. So put that in. Looks like they're both there, right? So kind of neat that we could do that too, right? So this new line of y equals 40, or h, I guess, right? Height equals 40. And so those intersects can give you when it's at those heights. So just an extra thing for a bonus. Yeah, so you should find all these pretty straightforward. You graph it, and then you can answer some questions here to do with it. It says, like, why do we only use non-negative values? In other words, like height and distance. You're interested in how far it goes. You're not interested in the negative version would be like before you launched it, when it burrows into the ground and stuff. It just doesn't really match reality. So what's the ball when you hit it? What's the maximum height? How far it travels, and so on. All those should be pretty easy to answer based on the graph you see. All right. All right, good stuff. Hope that helps, and I'll watch for questions if you have any. Okay? See you later once I figure out where to log off. Here we go.